Question A asks us to list an appropriate observation that provides evidence of a chemical reaction between the two compounds. As you can see in the chemical equation, it shows that PbI2, a solid compound, formed as a product from the two reactions. Question B asks us to calculate the number of moles of each reactant. So, to find the moles of PbNO32, we have to use stoichiometry. We are given 0.150 grams of lead-2 nitrate, and we have to convert that to moles. To do this, we have to divide the mass of the compound by its molar mass of 331.21 grams, which gives us 4.53 times 10 to the negative 4th moles of lead-2 nitrate. Then, to find the moles of the sodium iodide, we have to use the equation molarity times volume equals moles. But before we do that, we have to convert the 125 milliliters into liters. We do this by dividing it by 1000 because 1 liter is equal to 1000 milliliters, which gets us 0.125 liters. So then you multiply that by its molarity of 0.1, and you end up getting 0.0125 moles of sodium iodide. Question C asks us to identify the limiting reactant. Firstly, we'll calculate the moles of sodium iodide from the 4.53 times 10 to the negative 4th moles of lead-2 nitrate. So we simply multiply the moles of lead-2 nitrate by 2, because for every 1 mole of lead-2 nitrate, there are 2 moles of sodium iodide. I figured this out by using the coefficients of the balanced chemical equation, as you can see here. We end up getting 9.06 times 10 to the negative 4th moles of NaI. Because we originally started with 0.0125 moles of NaI, we know that the lead-2 nitrate is the limiting reactant because it produced a significantly less amount of moles. And as you can see, 9.06 times 10 to the negative 4th is clearly smaller than 0.0125 moles. Question D asks us to find the molar concentration of NO3- in a mixture after the reaction is complete. To do this, we have to use the equation molarity equals moles of solute divided by liters of the solution. So we multiply the 4.53 times 10 to the negative 4th moles by 2 because there are 2 moles of NO3 in the balanced equation, as you can see in this. Then divide by 0.125 liters because the problem lets us assume that no change in volume occurred in the reaction. So we end up getting 7.25 times 10 to the negative 3rd molarity. Question E asks us to identify which one of the diagrams listed best represents the results after the mixture reacted completely. So immediately, we can cross out the one on the top left because it says that no precipitate forms, which is clearly wrong because in the equation it states that PbI2 is a solid compound. Using that information, we can also cross out the one on the bottom right because it has the lead-2 nitrate as the precipitate, showing that no reaction occurred. Since the lead-2 nitrate was the limiting reactant, we can assume that means all of the lead was used up in the reaction, leaving no excess lead. Therefore, we can cross out the one on the bottom left because it shows lead as an ion, not in the precipitate. Taking this further, if the Pb was the limiting reactant, there would be some iodine ions left over because not all of it was used up in the reaction. So we can cross out the middle one because it shows no iodine ions floating in the water. Therefore, leaving the diagram on the top right to be the best representation of the reaction.